First of all, we fill up the tank until 3/4 of the tank size. And then we place the tank at the middle of the funnel. And then we install the impeller until a certain height and saturate the height. Then we switch on the switch, on this one and wait a little while until the RPM reach 50. And then until when the RPM reach 50, we increase the RPM until it becomes 100. And we we take the result, which is how the flow of the water by looking at the bead. For the experiment, the first thing is we pour the water until the height of the water is 3/4 of the tank height, and we place the tank at the middle of this thing, and then we install the impeller until a certain height, and we take the height. Then we put the beam to show us how the motion flow of the water. So to do the experiment, first we switch on the impeller and we wait a little while until the RPM increase to 50, and we increase the RPM until 100, and we look at the motion flow of the water. So after that, we take the result and we increase the RPM to the second one, which is 300. And then we look at the motion and we take the result. So lastly, we increase the RPM until 500. Then we look the motion flow of the water and we take the result by looking at the flow of beam. Second part, we increase the height. We do the same thing. We switch on the plug. We wait until the RPM reach 50, and we increase slow by slow for the 100, 300 and 500. So first 100. Okay, this one. Okay, this one is 400. So we take the result. Then we change to 300. Okay, look at the flow and we take the result. Lastly, we change it to 500. And we do the same thing. We look at the flow of the beam and we take the result. We want to install the buffer. Now we repeat the experiment with the baffle install. As you can see, this is the baffle. We have right now 4 baffles, and we're going to measure the motion at 100 RPM. As you can see, with the baffle installed, this is the motion at 100 RPM. Now we're going to 300 RPM. And this will be the motion at 300 RPM with the baffle installed. And we will now increase to 500 RPM. And this will be the motion at 500 RPM. And this is all recorded at the minimum clearance of the impeller. Okay, we repeat the experiment with the impeller shaft at the maximum height with the baffle installed. So we're going to the 100 RPM. As you can see, this is the motion of the fluid at 100 RPM at the maximum height of the impeller, and we're going to increase it to 300 RPM. And this will be the motion of the fluid at the 300 RPM with the baffle installed, and we're going to increase it again at 500 RPM. And this is the motion of the fluid at 500 RPM with the impeller shaft at the maximum height and with the baffle installed.
Previously, the experiment is done on a dismounted flat blade impeller, and now we will change the parameter of the type of blade impeller to any one which is the shrouded flat blade impeller. Okay. For this one, the experiment is done without buffer and is at the minimum height of the impeller shaft itself. Now we will change it to the 100 RPM to test the motion flow. Okay, as you can see, this is the motion flow of the liquid at 100 RPM. Now we will change it to 300 RPM. Okay, this is the motion flow at 300 RPM, and finally is the motion flow at 500 RPM. As you can see, this is the motion flow of the liquid at 500 RPM, and this experiment is done with the shrouded flat blade impeller without buffer at a minimum height of the blade impeller shaft itself. We have changed the type of blade impeller. Now we will do the experiment on the maximum height of the blade impeller shaft. Okay, now we change it to the 100 RPM. Okay, this is the motion flow for the highest maximum height of the blade impeller at 100 RPM. Now we change it to 300 RPM. This is at 300 RPM, and lastly is the 500 RPM. And this is the motion flow of the liquid at 500 RPM.
For our next part of the experiment, we're going to study the influence of the baffle in the mixing process. First, we use the shrouded impeller, as you can see, at 100 RPM. And we can see that there is almost no movement of the beads. Means that the mixture is still not effective. Then we increase the RPM to 300. After we increase the RPM to 300, you can see there is the more chaotic movement of the beats. Means that the mixture is more effective than the previous one. And we increase again the RPM to 500. As you can see, as we increase the RPM, there is more chaotic movement of the beats, means that the mixture is becoming more and more effective. And as we're using the baffle, we avoid the vortex, and the mixture is more effective. For the second part of the last part of the experiment, we are going to increase the height of the shuffle. So the maximum height that the range is 14 centimeters. Then we are going to do the same thing, looking at the different RPM. This one is 100. As you can see, there's no significant movement of the beats. Then we increase to 300. At 300, you can see the beat starts to move a little bit more faster. And for each RPM, we have to calculate the Reynolds number using the viscosity, the density, the velocity of the RPM velocity of the fluid. Then we can calculate the number of hours to determine the power consumption of the motor. We increase a little bit more the RPM to 500, and we can see there is a chaotic movement of the beats, means that the mixture is becoming more effective. So to calculate the power consumption, we just use the RPM at 100, at 300, and at 500. Then with each RPM we calculate the Reynolds number. After the Reynolds number, we determine either is laminar or turbulent. Then we use the mathematical relation to determine the power consumption.